Okay, our next presenter is Alexandra Kegel. She's a third-year PhD student in chemistry, and she knew she wanted to study chemistry in high school. She had an amazing teacher who inspired her interest in why the world works the way that it does. So the title of her presentation is Wiggle With It, Correlating Structure, Motion, and Light Emission in Perovskites.
Today, I would like to talk to you about white light. Our typical idea of white light is the sun, but artificial white light is in our everyday lives. From the headlights on the car or bus you use to get here, the lights overhead, the light in the TV, and especially in our personal technology. White light comes from a combination of a broad range of colors, from red to purple, like a rainbow. And current technologies, like light-emitting diodes, or LEDs, use multiple components or colors in one device to create white light. But using multiple components can give rise to issues with device efficiencies, fabrication, and lifetimes. We all know that sitting in office lighting all day can hurt our eyes, put us in a bad mood, and is no substitute for sunlight. So wouldn't it be nice if we could mimic sunlight indoors, or on the headlights on your car, or on your phone screen, and do it with just one material? This would be easier on our eyes and more efficient than current technology. I am currently studying single materials called hybrid perovskites that emit tunable white light. Hybrid, meaning they contain two layers, a wiggly organic layer that contains carbon and hydrogen, and a rigid inorganic layer that contains metals. Perovskite, meaning the structure, or how those layers are organized. And the structure is what provides for tunable white light emission. The inorganic layer has been studied extensively, but the role of the organic layer is still unknown. I am currently investigating how the organic layer motion contributes to white light emission. And what I have found so far is that how fast the organic layer moves or wiggles affects how much white light is emitted. If the organic layer moves more slowly, there is more white light emitted. And I can change how fast the organic layer moves in lab. And this provides an opportunity to study how the organic layer contributes to white light emission. If I change how fast the organic layer moves, I can then change how much white light is emitted, if any, like a dimmer switch. But to implement perovskites in devices, we must first fully understand them. My research provides an opportunity to advance technologies that could use single materials to generate white light. And as a society very dependent on artificial white light, we need to take steps like using perovskites, and find alternative methods to generate more efficient white light and bring the sun indoors. Thank you.